So as I just said, if you noticed, I didn't have a spot for 2A and 2B homework. So if you want to go submit 2A and 2B, you can go ahead and do that. I'm not going to count that late. I kind of messed up on that. If you send it through an email, I would really prefer you to resubmit it through Blackboard. And if you don't resubmit it through Blackboard, I guess I will go scrounging through my emails to double check and make sure I don't give anybody 0 that turned it in. So say that with when it's being recorded. Sound like I'm echoing myself probably, but better to say it twice than to say it none or once, right? Probably. The other thing that was 2A, 2B, today we should be doing 3A and 3B, which is the percentages and putting numbers into perspective. So hopefully you've watched those videos already. The homework is, what do I want to say? Not the homework. The lecture notes, that's what I was going for next. The lecture notes for 3C and 3D are up, and the video should be up pretty shortly. The other thing is the test. I'm still working on test. So I'm like hoping, really hoping to get those things through by this weekend. Hopefully sometime they will get graded. Easy there. Okay. Okay, so any questions over anything that's happened so far in class, like where we're at, what we're doing?
Yeah, I have a question. So I did do like a little tutorial for my calculator. I don't know it said it in the chapter, but I've been noticing when I do the like 10e6 to do the like 10 to the 6th power, it's adding an extra 0. So do I just have to account for that and type in one less, or just like write it out by hand? Okay. Sorry, that sounds aggressive.
No, I know what you're talking about. So let me, there is like a little calculator app I have. I could probably show you.
Yeah, it's really messing with my calculation. So
you don't need to put the 10 in there, I think is what you're doing. You're putting like an extra 10. The E means times 10. So like if I want to do.
Oh.
Yeah. So let me maybe switch to my camera and switch this view. Let me get to my view. So what it sounds like is if, I don't know, we have like 3 points or something like that.
Yeah.
So it should be 3.8. And then this whole thing is just an E. And I just need the exponent now, which is
okay.
12.
Yep, that was it. Thank you.
So it's just E and then the exponent is all you put. And that's scientific notation in your calculator. It's a little bit weird. It's like we're rewriting this whole thing with just one symbol.
Okay, cool. Thank you.
Good question. Okay. Are you ready to get started on this homework? Percentages. Okay, so we talk about this thing called absolute versus relative change. So absolute change is, I think that's pretty straightforward. What if I want to do absolute change? What am I doing to these two numbers?
Subtracting.
Yeah, it's exactly it. Just a subtraction. It's just the difference of what, 16.1. And so this says this, well, I guess I should read the instructions, right? I'm getting too hyped up on my coffee or something. Find the absolute change and the relative change in the following cases. So if we want to know absolute change, my absolute change is this between the two. So I want to know what the increase is going from 8.7 to 16.1.
That's what I did. 17 minus 8.7.
Yeah, should give you what? 7.4. 7.4. That's my absolute change. If I want to know my relative change, it looks like that thing on top, but what goes on the bottom? What are we comparing this to?
The 7.4. So isn't 7.4 on the bottom?
No. The 7.4 is going to go on top.
It'd be the referent, so
It'd be the
8.7.
reference. Yeah. And there's a few different words they might use. The words that I usually do is like new minus old over old. And full disclaimer, and they may not be new and they may not be old, but that just like, I think most people understand what I say when I say like this. What do we start out with and what are we going to? The thing we start out with is the 8.7 and it is going to 16.1. So we're taking the difference and we're taking that difference and we're comparing it to like sort of the original number to get like a percent increase on this thing is what essentially we're doing. So this is 7.4 over 8.7. So this is going to be a nasty decimal. So 7.4 divided by 8.7 is going to give me like 0.8505, 06 or something. Somewhere around there. So it's giving me that decimal. And there's something else on this formula. I didn't really write it. But what should I do with this decimal?
Multiply times 100%.
Yeah, we should really convert this to 100% or to a percentage. So multiply by 100. This should give you 85.6%. So if I'm being honest, a lot of times I probably won't even write the like convert to a percentage thing on there. I'll probably just leave it off. I think at some point the book does it too, so I feel somewhat validated in doing it. Does that make a little bit of sense? Maybe 7.4 to 8.6.
Yeah,
or 8.7. So yeah, 100% would be 8.7 over 8.7, right? So this would be a little bit under 100 probably. So we can. I'm hoping y'all do this. Like, hopefully we can like kind of guesstimate these things a little bit. Try to make sure we're in the same ballpark as what we should be, right?
So yeah,
if this one's larger, then it's going to be over 100%. If this one's smaller, it's going to be under 100%, right?
So I got to remember.
Huh? You got to remember something, but I didn't hear what the rest of that was.
I said I need to make that decimal a percentage.
Oh, yeah. And I think in the formula in the book, they did tell me to do 100% multiplied by.
Yeah.
Right. The book says that, and it was in my notes. So I'm being maybe a little bit lazy, but we should remember to convert this. This is a percentage. Yeah. 47 says I'm going from where to where? 67.8 to 55.4. So this one's like my old, and this one is kind of like my new. Maybe this might be a little bit weird. Because when I do new minus old for my absolute, what sort of number am I going to get here?
So this is 67.8 minus.
What sort of number? Like, what's the sign on the number, I guess is what I'm really asking, right? I hope you all notice that.
Could you move the paper up, please?
Yeah, I don't want you to see this now. What's the sign on this thing? What if I'm going from something? What if I'm going from 67 to like 55?
It's gonna be negative.
It's gonna be negative, is what I'm trying to get at before I throw it down. So the number, the difference between them is 12.4. Since the smaller one is coming first, it's a negative 12.4. This thing is going down is what they want you to realize. We can have negative absolute differences. And so that's the absolute.
So was I supposed to know that there was a negative? I thought I was subtracting the 55 from 67, but
so in this one, you should sort of know. They're giving you an old one and a new one. Has an old one and a new one, right? These problems have an old value and a new value. So it should always be new minus old over the thing that you started with. So this one, we're going to go 55.4 minus 67.8. It's going to give us a negative 12.4. On top, this thing should be the same. We're still doing a difference, but we want to compare this to the whole, which is. You gotta be careful on this one too. So what number am I putting on bottom?
67.8.
Yeah, it should be the 67.8. New minus old over old. These two should hopefully always match up if you do it correctly. It's always the thing you're starting out with. So if you wanted to skip a step on your relative and you're in the absolute, you probably skip that step if you really wanted to.
Yeah, that's what I did. Now that's how I did.
Fine, yeah. Mine's 12.4. And we're dividing that by 67.8.
And times 100%.
Yep. 1.8. I'm getting like 1.829. So this is something like 29%. And the important thing is this is what?
Percentage. Negative.
It's got to be negative because it's going down. So this is telling me it decreased by 18.29%. So this one is 18.29% less than the other one. There's another way to say it, right? That was the vocabulary they would really like to use.
Can you move the paper up?
Right there.
Oh, okay, that was it. Okay, yeah.
That's it.
I got it. Yeah.
So what is the question? How do you write the answer?
Just negative 18.29%.
No, not the numerical answer. The question answer.
That's all they're asking for. Is this for this absolute difference, or is that what? Is that the word they're using?
So do I say the difference?
Change? They're asking for the absolute change and the relative change. So the absolute change is minus 12.4. The relative change is minus 18.29%.
Okay.
I gotta see. Oh, there we go. That's better. I really don't like zooming full screen. Like, you can't see certain things. They hide the time from you. Okay. We're moving along here at 49% comparisons. So we want to complete these sentences. Life expectancy at birth of American women is 81.2. This is blank percent greater than the life expectancy of men. So I think maybe this might be one of those situations where you have to ask like maybe of versus more than and what those sorts of things mean. What if I want to know how much greater it is than that or percent greater? What are they asking for?
The life expectancy of a woman and the life expectancy of a man.
And they are asking for the relative difference between these two. So we want the relative difference. And I'm using the words old and new just kind of generally, so don't like put too much emphasis on that. But what are we starting with? What's the first thing that they give us?
81.2.
Yeah, so I'm pretty sure this is their old or their reference. They use the word reference, right? I'm just going to keep saying old. Because if you remember, I went through the notes, and there was the old and new sort of thing we did that started it, and then we went to the reference values, and it's the same formula either way, basically, right? Now we want to do new minus old. Ooh. Wait, is that what they're doing? No, wait.
It was old minus new. Okay, I'm confused.
We want to know how much greater this is than this. Ooh. So which one is their reference value? And it kind of says it within the wording of their question, and I kind of wrote it wrong. So I guess that kind of gives it away probably, because it's like if it's not one way, it's the other, right? If we want to know how much greater this one is than this one, I'm hoping like most of you can figure out, we're going to end up subtracting the larger one from the smaller one, right?
Right. Yeah. Okay, that's right. Okay, I did that right. Okay. That was 11-2.
Is that what they're doing? Wording's a little weird on this problem, to be honest. I don't really like it. I'll try to do.
Yeah, I was a little confused on this one.
Let me double check, make sure that's what they're doing. 81.2 minus the 76.4, and we're dividing that by, that one should be, and that is problem, which one now? 49. Yeah, that's what they're doing. Okay. Yeah, I'm not a big fan of the wording on this one. But this is the one thing that's greater than means you should be getting a positive difference, right? And if we do the subtraction this way, then what is our reference value going to be? This kind of makes out what our reference value is going to be.
I'll put 11-2.
It's going to be one of these things.
76.4.
It should be the 76.4.
Oh, wait. Okay. Oh, so you don't put the answer on the top?
If you wanted to say this is old one, this is kind of like new minus old over old. The answer on the top, are you talking about the 81.2 minus the...
Yeah, 76.4.
76.4. That's the first thing I'm going to do, which is going to give me 4.8. 4.8. Right? Hopefully.
I did that right. Excellent.
And we take this, we divide it by 76.4. So definitely, hopefully, you got some sort of calculator you can do this with. I'm getting like 0.0628.
6.28.
Yeah, and so this is about 6.28%.
Yeah.
And so the life expectancy of American women is about 6.28% greater than the life expectancy of men.
I don't know where that 11 points
at. Ooh, I almost forgot how to drink for a second there. Ooh. Okay, in 2015, the median age of the first marriage of U.S. women was 27.1. Was blank percent less than the median age of the first marriage of men at 29.2. So this one, again, the words are kind of telling you which direction you should set up the subtraction. So which way should I subtract these?
29.2 minus 27.1.
If it's going down, I should really put the smaller number first, right?
It's going down.
They want to know how much this is less than this thing. So this less than is indicating it's going down, right? So I should really start out with the smaller number of 27.1, and I should subtract that from the 29.2. And if I do it this way, this should sort of define what my reference is. My reference here is which number?
29.2.
29.2.
The 29.2. Figuring this thing out, I'm subtracting 27.1 from 29.2. This is giving me a minus 2.1 over 29.2. If I divide these two numbers, should be getting like a negative 0.719, somewhere in there. 71917.
I've got a question.
Yeah.
When figuring all this out, is it going to be necessary to put like the years, or can you just put the numbers, plug the numbers in and just go right at it?
What do you mean the years? So like putting these numbers in?
Yeah, so like is it right 27.1 years minus 29.2 years? Or can you just put the numbers and you automatically know what I'm talking about when solving the problem?
So it sounds like you're asking me like how much of this work you need to show, right?
Yeah.
Yes, exactly.
Okay, so like this is the sort of thing like show as much work as you kind of feel like you need to, but like this is the sort of thing like if you get something incorrect, right, and you don't show any work, then I can't give you any credit. Like I can only grade stuff that's there. And so there's a sort of thing like you can skip some work, but you kind of doom yourself by doing it sometimes. And to be honest, I want to see some work in these problems. There should be at least probably this setup, or at least like this thing. You should really be showing some work somewhere. These aren't too complicated. You might be able to do this without showing work, to be honest, on like one like this. But there's like a word problem where you actually like, you know, where it takes a significant amount of work. If you were to like to do a word problem that was like a lot more work, not just something really simple like this, and you just like throw down an answer, to me like that looks really suspicious. And when it's like something I would have to show a lot of work for, and a student that's like in my class is just like, here's the solution, it's like, where's that coming from, sort of thing, you know? So to be honest, it depends upon the context and it depends upon the problem. Something like this, I would suggest like showing at least a little bit of work, because if you get this number wrong and you still set it up right, you would still get a pretty good amount of credit for it. So it's like, it's one of those things, it's like, how much do you want to doom yourself, sort of? Is that a sufficient answer, or is that just too general and vague? I don't know.
That sucks. I mean, I was just, you know, trying to, I just want to know, like, really, if you could just put 27.1, like how you have it written on the paper without having to write years down to go with the numbers. You know what I mean?
Oh, right, in the units, years? Is that what you're talking about?
Yes,
Oh, no, I'm not expecting you to write out every little detail like that, no.
Okay.
No. Just the number's good. Because here they just want the difference too, right? All they really want is, and we hadn't done it yet, I should really convert this to a 19%. I should really convert that to a percentage. This is the thing that they really want on your paper, right? So the years is kind of insignificant to finding that number, to be honest. Or to me, I don't know.
I think that's what I was trying to say, but for number 47. Because I didn't know how they wanted to pronounce it, what they wanted to say, answering the question. I guess that's, thanks, Tony. I appreciate that.
Okay. So was that 45, 47, 49, 51? Okay. These, there's a lot of problems on this section, but they are all fairly like quick. Like, what is the relative difference, or what is this of versus more than? So if we see the population of Hawaii is 52% less than the population of Arkansas, the population of Hawaii is blank percent of the population of Arkansas. So this versus more, you want it to look like 100 P, you want it to look like 100 minus P. So what should we do here? What are we thinking about here? If Hawaii is 52% less than, then what is the population of?
$163%.
Where are you getting 63? I'm seeing 52.
I think he's on 51 or 53.
53? Are we supposed to do 53? Was that one of the recommended?
Yeah.
Yes.
It was? Okay. The population of 50% greater than the population of the mixed population. This will be correct. If you're going 63% greater, it's 163% of. Was that on the list? Did I just miss it? It is on the list. Okay, so I guess I forgot to mark it. this one would be greater than would be like the 100 plus.
Yeah.
Because
I missed question 53. So I'm just gonna write it down. I did this, but I missed the number 53 question.
All right. So 53 is like we're taking Michigan is 63% greater than Missouri. So to get it 63% greater, like essentially what we're doing is we're taking 100% of Missouri and we're adding another 63% of Missouri to get a whole total of 163% of Missouri. Does that make a little sense, hopefully? But we have to take one of this and add it back to the 63, right? And this is how we're getting this 163. Now we're looking at this. If Hawaii is 52% less than Arkansas, then it is blank percent of the population.
So you'd subtract it?
Uh-huh. Subtract what?
100 from 52.
Vice versa, yeah. 52 from 100, yeah. Which is what, 48? So Hawaii is 48% of the population of Arkansas. This is like the 20% off sale, right? If it's 20% less, then you're paying 80% of the price. Same sort of thing. The of versus more than. So you should be able to convert from less than more than to of, and technically you should be able to convert probably the other way. I don't think we did that quite as much, but it should hopefully be something that you can do. Okay, so 57, the wholesale price of a toaster is 30% less than the retail price. Therefore, the wholesale price is blank times the retail price. Are they looking for the percent in these ones, or what are they looking for? 57. Oh, okay.
It's
What percentage would it be?
75.
30?
Oh wait, 70.
70, yeah. 70 sounds better. So 70%. They want to know what number you have to multiply it by. So they don't want the percentage, they want the decimal. So we got to convert this to a decimal, which is 0.70 or 0.7. So you would have to multiply it by 0.7 times the retail price to figure out what your wholesale price was. Did I say that? Is that making sense, hopefully?
Yeah.
If we want to do 70% of something, we have to convert it to the decimal before we start multiplying, right? Same thing with 59. The original retail price of a TV is 20% more than its on sale price. So therefore, the retail price is, if we're doing percentage, what would the percentage?
$80.
So it's 20% more.
Oh.
If you're paying 20% more, how much of the price are you paying?
120%.
You're paying 120. You're paying one of the prices and you're paying 20% of it. Right? So you're paying 120. What number would you have to multiply by?
1.20.
1.2, 1.20. Yes, that's exactly it. Okay. Okay, percentage of percentages. So the percentage of Republicans in the House of Representatives increased from 40.9 in 2010 to 55.3 in 2016. So they want us to describe these in two ways, in absolute change and then in relative change. And they tell us like what format it's in, which is not fun. So if we want absolute change, we've done a few problems like this. What am I subtracting from what here? Huh?
55.3 minus 40.9.
Yeah, exactly. And so I'm doing this, let me do it. 55.3 minus 40.9. I'm getting something like 14.4. And this is probably the important thing to talk about when we're talking about percentages and percentages of percentages.
What number is that again?
This is 61.
I missed that.
So what words should I put after this 14.4? And they kind of tell you right there in the thing, percentage. If it's an absolute difference in percentages, the word that I talk about so don't, whatever you do, don't put the percent sign. Don't say the word percent. Say the word percentage points. That is just the raw difference between two percentages. This went up 14.4%, right? Percentage points. I shouldn't say percent. It went up 14.4 percentage points. The relative difference I'm hoping like these things start filling themselves out pretty soon because it's all kind of the same pattern, right? If this is my absolute difference, my relative difference should look like that thing on top. And if that thing is on top, guess what number has got to go on bottom?
40.9.
That 40.9 has to go on bottom. So now I'm figuring out what 14.4, 40.9. And then I got to convert it to a percentage. I'm getting 0.3521, somewhere around there if I round up. And this one, how do I talk about this thing? This is the one I talk about percent. So this is a percent change. And this is a percent of a percent. We're talking about 35% of the 40%, right? Is going to give us that 14.
Professor, I got, wait, hold on. I'm on here. Oh, yeah. Professor, I got 0.352078.
Yeah, so round it up.
When do I stop? When do I stop doing the numbers at tens, hundreds, thousands, or 10,000s? When do I stop?
So in the end, I usually like when you're done with everything, in the end for it to have like probably at least 2 decimal places, if not 3. Like going for 2 to 3 decimal places usually.
Okay. 35.
I'm a lot more interested in you actually doing the correct work and stuff like that than being precisely accurate and rounding to the right decimal place, right? As long as y'all are doing good, correct work and you understand the concept there, I think is the more important thing. Okay, so y'all look busy. I'm like writing stuff down. I don't want to yank stuff away from y'all if y'all are busy writing it. But I guess y'all would be yelling at me if I'm going a little too fast. So. Now we're still doing percentages of percentages. Alcohol use by high school seniors decreased from 50% in 2000 to 35.3 in 2015. We are going to talk about some topics today, apparently. Okay, so this decrease from that to that. So are they wanting to do 2A's absolute? So if we want the absolute difference between these two, how am I writing that? This one might be a little tricky. What should I put first?
35.3.
Yeah, that 35.3 should be the first. Should be subtracting that from 50.
Leave me alone. No.
This is decreasing. Uh-huh. So I'm getting a minus 14.7 on this thing.
When we're writing these out, if we're like already saying it decreased by this many points, we don't need to put the negative in front of it anymore, right? It's only like if it's just the number point that you want to signify that there was a decrease.
Yes, this negative just represents that there's a decrease. If you're using the word decrease, then that's sufficient to represent that it's going down.
Okay.
So if you said this decreased by 14.7, and what's the word you would use?
Percentage points.
Yeah.
Oh, Lord.
Percentage points.
So don't put percentages, it's percentage points.
Don't put percentages, don't put the percent sign. This one is the PP, the percentage points. This refers to the raw sort of difference between those two percentage numbers. If I want to know relative, the relative difference, this top should look the same as my absolute. So if you're writing this differently, you're probably writing it wrong. And I'm putting this over.
14.7 over 35. Okay, I thought it was 14.7.
Over 50.
Oh, man.
Gotta go over my reference. Yeah, if you put it over 35.3, you're not going to get the same percentage. It's going to be a different base. So minus 14.7 over.
Okay, that's how I did it. I always do it like that, man.
I think if we just multiply that by 2, we get the percentage, right? Over 50. But let's go and do it. Minus 0.294.
0.294. So 29.40.
So this should be the important thing.
Percentage.
Negative 29%. And so this is the one you either write the percent sign or you say.
Okay, so when I do relative, it's percent.
Yes.
And when I do the absolute, it's percentage points.
Yes.
Gee.
That's the vocabulary there to talk about them things.
Oh, okay.
So this is actually a percent change. This is not a percent change. It is a change in the percentage points that they're talking about. This is a percent of a percent. So.
She said 2.
And then if you take the relative differences of the relative differences, then you have a percent of a percent of a percent. We can keep going that way if you want, but probably doing it once is enough. Yeah, let's just like no. We're like the annoying kid that never knew when to quit. That's what mathematicians basically are. It's just like, can we do one more? Can we do one more?
Oh, man.
Can we do another percent of a percent of a percent?
I just have to remember that absolute is percentage and relativity is percentage.
Yeah, because this is not actually a percent change, right? This is not relative to something. This is actually a percent change. It's relative to whatever your reference value is. And so this is a relative sort of thing. I don't know. 14.7 is about 30% of 50, right? Is what this is saying.
Okay.
But here we just have a raw, this is just a raw number 14.7. There's nothing that this is being compared to. Nothing's being divided. Yeah, so it's definitely, you got to get used to the vocabulary on them things. I don't know what else to say, right? But there is a sort of vocabulary issue that happens there. And trying to understand that. Solving percentage problems. More we got in this section.
Is it 67 or what?
67 is what we're on. So the total after-tax cost of a laptop is $1,278.24. The local sales tax rate is 7.6. What is the retail pre-tax price?
So do we change the percentage to a decimal to do the equation?
Yeah, so we're going to convert this to decimals, probably one of the first things. So this is going to be what?
That's going to be 0.076.
Yep. The 0.076 is what that 7.6% will be. And I want to think about this. I have a pre-tax and I have like a post-tax sort of thing. So this is the thing that's happening after tax. And we know the tax rate is 7.6%.
So we subtract from 1278.
Yeah, well, you got to be careful with how you're setting this thing up. Because we know there's like a pre-tax. We're going to add tax. And we're going to select the retail. This is one sort of way maybe you could think about it. The sort of way I would probably think about it is we have one of these things and we're adding 7.6% for our tax. But what is this 7.6 based off of? Is it based off of this pre-tax? Is it based off the pre-tax or is it based off of this retail price?
Retail.
So this 7.6 should be based off of your pre-tax, because before we do the tax and add the tax, we don't even know like what retail would be, right? If this was like something that we're doing in our store, they come up with the pre-tax price. And the way that we figure out taxes, we take this pre-tax price and we add 7.6 of the pre-tax price back to it. And so if we're taking one of these prices and we're adding 7.6% to it, we're increasing it by 7.6%. One of the easier sort of ways to think about that is that's what percentage?
Percent. And you said we're doing it twice. So we're doing it twice. We're doing 7.6 twice.
No. We're taking the pre-tax,
which is 7.076, right?
We're taking one of those. No. So we don't know what the pre-tax price is. We know tax is 0.076 of something, right? But we don't know what that something is. That's the pre-tax price.
Right.
I could say pre-tax. If I take the pre-tax, right, I'm taking the pre-tax price, I'm adding like the 7.6% of it.
Don't you divide it?
Yeah, so we're going to end up having to do some division here eventually. So I think you're going on the right steps. So 1, 2, 7, 8.24. Trying to get people to combine this thing. If I have one of them and I'm adding another 7%, how much is that?
Another 7. Jesus.
This was going back to that first page. If I have 100% of something and I'm increasing it by 7%.
Oh, 176.
I have 107.6%, right?
Right.
176% of this pre-tax price is going to be the final price, the retail price. So someone was saying already, but this is 107.6%. What we're going to end up doing to get pre-tax price. We're going to end up dividing because we have to divide that thing out. And so this should give us our pre-tax. Where am I at? 1, 2, 7, 8, 2, 4, and I'm dividing by 1.076. This one is probably one of the more complicated forms. They can either give it to you kind of straightforward, or they can give you it kind of backwards, I guess is what the way I would describe it. This one is kind of backwards, right? We can't just take 107.6% and multiply it by a number and get to the final thing. We're going to end up doing some division and working backwards to figure out what our old price was. So when they give you the new price, that's when it's hard, right? If they're giving you the old price, it's usually easy to calculate off of. Like if they gave us a pre-tax price, all we'd have to do is 107.6% of pre-tax, and we're done. 1.076 times whatever the heck they give us. This way is backwards, so we're going to end up dividing by 1.076. And then we can do a sort of check. So if it's
is it 120, is it 1278 divided by 1076?
Yeah, it's 1278.24 divided by 1.076. And that should give you somewhere around 1187.96.
11, yes, 90, yes.
Okay. Is that right?
Oh. Yes,
that's it.
That's it.
I rounded up, I think, right?
Rounded off 955, so I had to round it off.
Rounded up to 96. That's good. So does this make sense? Like, let's sit back and think about it. Makes sense. Have 1187 and this other price is 1278. So pre-tax is this. This is post-tax. Does that make sense? Like, in the grand scheme of things, should your post-tax be more than your pre-tax? Hopefully.
So can I ask a question? Do I start off this being 7.6, right? I change that to the decimal and I multiply it by 2. Is that correct?
No, you're not multiplying that by 2. So basically, let me step back and maybe talk about what we're doing. We're taking one of the pre-taxes, or one of the pre-tax price. So we're taking 100% already. We're going to add 7.06. So we're going to add 1.76 of whatever the heck the pre-tax was. That's the thing we don't know.
Okay. So
and when we do this,
we don't know it's going to be 100%, correct?
Yeah, and like this is usually the way if you're figuring tax on a price, you go 1.0825, right, is our tax.
Right.
You usually do 108.25% of whatever the number you're doing. If you've ever had to work retail and then your registers go down, you know, the system goes down, and then they make you whip out the calculator that's got the dust all over it from like the closet, and it's just like 1.0825, and you multiply it by whatever their total was, right? Yeah. And then this is giving us the post-tax price, which is 12. And so this is kind of what I'm expecting maybe for like the setup, or even if you know how to do the next step. And so this is multiplication. So to get rid of this, we're going to end up having to divide. So if we were solving it this way, the straightforward way, it would be multiplication. If we're doing some back solving, we're going to have to do some dividing. So our pre-tax price. Okay. 7. What's the next one? 71. Okay, well, let's get on with 71. If a national unemployment rate decreased in 3 consecutive years, then the rate decreased by 6% over the 3-year period. Okay, so I think we have gotten through like the section that they call uses of percentages. Now they're trying to see if they can like kind of throw you something that might go awry. Why is it frozen? Well, there we go. Not frozen no more. There we go. Okay, so 71, if the national unemployment rate decreased at an annual rate of 2% per year for 3 consecutive years, then the rate decreased by 6% over 3-year period. Is this true? Is this not true? What would you say?
I said false.
Huh.
I said not true as well.
Okay, so let's maybe go over like maybe an example. So pick a number. I don't know. 1,000's usually a good number. 100, 200 usually a good number. The national unemployment rate decreased an annual rate of 2%. So if we're going to take off 2% of 1,000, I think that's taking off what? 20. If I do 2% of 1,000, I believe that gives me 20. So the first year, I'm going to have what, 980? The 1,000. I'm going to have 980. The second year, what am I going to start with?
980.
I'm taking 980. And then I have to take off 2%. But now I'm removing like what, 2% of?
980.
980. And so I didn't do it here, but this is really another way to write this is the 2% of the 1,000 that I started with, right? And so you might notice already, we have this thing, we did this in the notes, 0.02 times 980. Minus 19.6 to 980 minus 19.6. But like 960.4. And this is year 2. And the last one is year 3, so we're starting with 960.4. So it's very very similar. The other thing you could do is you could just do 98% of that thing, right? I guess it's another way. You could do 98% of this, 98% of this, 98% of this, and you're going to get like 941.192. So I did this with 1,000 so that it would be like kind of easy to convert to a percentage. But if I want to convert this to percentage, it's 0. So this is going to be 94.12% of my original thing. If you want to do it with 100, then you're like right at the percentage, right? You don't have to do any shifting. If you just want to say start with 100, see what it goes. If it doesn't work for every number, then it's not a general rule, right? So we only need like one sort of thing where it doesn't work. So did this rate get decreased by 6%?
Not quite.
Not quite. It got decreased by a little bit different, right? That 0.12 makes it not exactly 6%. It would be like 5.88, something like that, I think. Whew. Try to break my calculator. Let's try it. Do it again. Nope, still works. Okay. Yeah, it's 5.88%, right? Would be what this was. So it went down by 5.88%. Not 6. So again, like I hope like you know like the solution to this thing, but like I hope you understand like why this is. And this is that problem they call the shifting reference. So here the 2% was talking about 1,000, but the next year the 2% is going to be talking about a different number. And here the 2% is going to be talking about a different number. So these aren't 1,000, right? And so this is shifting your reference value is what they say or what they call it. So your reference here is 1,000. Your reference here is what, 980. Your reference here would be the 960. So our reference value keeps shifting. If we shift the base amount, these percentages don't mean the same thing, right? They mean something different. So your percentage is just a ratio. If they don't give you a base amount, they're not really telling you a whole lot about what that percentage means. And so that's one way they can sort of manipulate you, just giving you a percentage, right? If I have a class of 10 people, if I have a class of 100 people, and I say it went up by 1%, I could be talking about like what, one person, right? But if I'm talking about 10,000 people, and I say it went up by 1%, I'm talking about like 100 people. This is pretty substantial, right? But they're both saying 1%. But depending what your reference is, it could be a substantially different raw number. So if they're not giving you the base number that you're basing your sort of percentage off of, it's a really good way to sort of mislead people. I don't know. I think there's something with birth defects with like women aging, and it's like they give a percentage. It's like, oh, it's so many percentage more, but like the number is so substantially small that the percentage doesn't really mean a whole lot. Okay.
Professor, I mean, I don't want to stop you because it seems like you're on a roll here, but I did that thing with 100. And so I kind of like messed it up a little bit. I put 100 minus 0.02, and then I got 98 for the first year. Then I went 98 minus 0.2. Was I supposed to put
96.04 is this next number that you should get?
No, but I used 100. I didn't use
it should be, yeah. It should be the same thing.
1.96?
Yeah, so all you're doing, you're starting out with 100, you're marking off a 0 there, you're marking off a 0 there, you're marking off a 0 there, essentially. Yeah, and now you're starting with 98, and you're doing 98 there, 98 there. And so essentially, this thing should be right there instead. You're just moving a decimal place over each time. But yeah, you should be getting the same thing. It should be 94.12%.
Okay, that's fine.
Okay, so 80 or around. Right, 80. 75. Determine whether the following claims could be true. Explain your answer. So Anna bought a surfboard online and saved 125%. That sounds like a good deal. I'll take it.
Sounds like they gave her money.
It sounds like they gave her money, so this is not happening. And this is not more than 100% that they're talking about, right? You can't have a savings of more than 100%. Okay, so average hotel rooms have increased 100% in the last 20 years. Is that possible?
Yes.
Yes, that means they basically doubled, right? Okay. What would they want? Do they want us to say okay or no? What did they say? So this is what, 75? Not possible, they say. Okay. They just say possible, not possible is what the book's telling us. Possible. Okay, that's possible. Average percentages. Suppose you have an 80% average in a class going into the final exam. You receive a 90 on the final exam. In general, does it follow that you're going to make an 85? So how are they getting that? They're averaging those two things is what they're doing, right? To get the 85. They're doing 80 and 90 average is going to give us 85. Is that a good thing to do?
Because there's another percentage.
Absolutely not. So in general, we do not average percentages, right? And we kind of talked about this. If there's like 10 questions on this thing and there's like 100 questions over here, these things are going to be weighted more, right? So I did an example in the notes where like an exam had 10 questions and a quiz had 100. So unless you're pulling from the same amount of problems, right, it's not going to be the same. It's only coincidentally the same, right? I guess is one way to say it. If you're right, is right by coincidence sort of thing. No, don't average percentage. Let's see. That should be what they say in the book. Let's double check. No, you cannot average averages. Okay. Same thing. Okay, 83 and 85 are done here at the bottom. We're doing more analyzing percent statements. So this is the same thing. We're trying to see if they're doing something legitimate or see if they're using one of those fallacies we talked about. 40% of the students at an orientation are women and 20% of the women are engineering students. Therefore, 40% by 20% would give you 8% of the students' orientation are female engineering students. Oh, this one might be a little challenging. Forgot what. If it works for 100, you might want to try something else then too, just to double check. But 100. What are we gonna pull out there? 40%? They said was women. 100.
40%, yes.
That is 40.
40% of the women.
Now we want to take more. We're taking 20% of what number now?
80 of 8 or 40.
We're taking it out of that 40. If you take 20% out of 40, that giving you.
So you get 0.8.
Yeah, so we go 0.2 times 40 if you really want to, right? But you should be getting 8.
Yeah.
And we could do this with a bunch of different numbers. But guess what? 40% of 20% or 20% of 40% is going to give you 8%. So this one, they're actually doing things correctly. I don't know how else to do it. I guess we could do it with X, right? Be my 0.4. I guess if you really want to do it with algebraically, with a bunch of X's, you could do it. But this is a correct formula, the way that they're doing this and the way that this is set up. And I'm not sure we had anything like this in the notes. This might be completely new concept to a lot of people, to be honest. So this isn't like the average thing like we were doing previously either. So maybe like making some points of distinction, like, hey, this isn't any of those things that we did have. But if we look at this last one, 50% of the cars in the rental pool have Bluetooth capability, and 20% of the cars have GPS. Therefore, 50 plus 20% equals 70 of the cars have Bluetooth or GPS. So this might be, it's a little difficult. But if you think back, I probably don't want to think back to that far. If you think back to the logic stuff, this does kind of relate back to that sort of logic stuff. We have two sets. We have one called Bluetooth. We have one called GPS. But like if I'm thinking about this set, drawing this text. Am I going to draw an overlap or no overlap? I guess is the question I'm asking. There should definitely be an overlap because there's certain cars that have like like both of them, right? And because they have an overlap, if 50% of them are over here and 20% are over here, if we add them together, what we're going to end up doing is like counting that overlap twice sort of thing. Mm-hmm. So I'm not sure how much more time I really want to spend on this. But 50% of the cars have Bluetooth, 20% have GPS. That's not accounting for the cars that might have both of them, right? And so there's some numbers that they're missing in here. We would have to subtract what is in both of them is essentially what we'd have to do. We'd have to subtract their overlap.
So is it, do you, on this 70%, it says Bluetooth or GPS. So are we going to differentiate the 70% between the Bluetooth and the GPS?
No, so they mean to count up this whole thing, right? And so I have one set. One set that looks like, all right, one's 50%. Add these two up. There's this middle section, and I know we went like briefly over it, but this middle section is going to end up getting counted twice. And so I actually have to like subtract what's in the middle of those two things. And so it's not actually going to be as high as 70% because there's this overlap sort of thing happening. There's cars that have both GPS and Bluetooth, and I'm not accounting for that here. So it should actually be less than 70%. Okay. Ooh, this is a long section. $85. Where am I at? I already did this one, Oh, these are the ones I have. Sorry. These are the ones that go through. Ooh. Okay. Record, and then we got one more page on this section, and then we got one more. The 4,550 men in the arena comprised 85% of the people in the arena. How many people were in the arena? There are a few ways you can solve this one, if I'm being honest.
Is that 85 from 100?
85 from 100. And what'd you do?
And then you would, I mean, is you subtract 85 from 100%?
I wouldn't do that. If you do 85 over 100, it's like you can compare this to a part to a whole. You can use like percentages as fractions to compare these things if you wanted to. That's one way you can go about it. And if I did this, how would I figure this thing out? What's my part and what's my whole?
Your part would be 4550, and then your whole would be X.
Yeah, exactly. That's the thing I want to know. That's the thing I don't know. So if you wanted to set it up like this, this is absolutely a good way to set it up. You can cross multiply 85 by X and then give me X 45. You could absolutely solve it like this if you wanted to. And then now you're going to divide by 85. Too many zeros. Okay, divide by 85 gives me what? 5. So I'm probably going to tell you to round to the nearest person. We don't want to be quartering people or anything like that in this class. So drawn and quartered. But we're talking about people, so I'm probably going to round it to the nearest person. Another way. If this is 85% of the people in the arena, 85% of the people So of literally means multiply. You could do 85% of the people is this other thing, which is 4550. Problem just set up a little bit differently. So if you wanted to take 4550 and divide it by 0.85, and this makes sense to you, that should absolutely give you the same number. So either way, that way or that way. Ooh, let me move it down a little bit. The equivalent fraction, or you could do the word problem like it is. Okay.
So you got the paper. Did you get 0.0186?
I don't get that anywhere. Nope.
Jesus, how did I miss? Where did? Oh, so multiply 85 times 450, 4550.
You're dividing this by this. And there are 3 zeros here. It should be 455 with 3 zeros. And then divide that by 85. Okay, the next one. In 2016, 84% of households with television subscribed to cable. An increase of 7.8% over 2000. What percentage of households with television subscribed to cable in 2000? I think, that's kind of worded kind of weird. This problem sounds like 7.8%. It might help you. And in 2016, we know 84% of the households had it. So this might be confusing because they're doing what? Percentages of percentages here? Okay. So what percentages of household with television subscribe to cable in 2000? So the thing that we want to know is this thing. What is this thing over here? So how do we get from this thing to this thing? We have to increase it by 7.8%. So if we're increasing something by 7.8%, another way of saying that is what percentage of?
Of 100?
The way we would do it. It's 107.8% of which thing?
Not the reference value. We don't have that. Never mind.
This thing. This is the thing we don't have, right?
Yeah.
And then this is going to be equal to whatever the heck over there, 84. So we're increasing this thing by 107.8% to get to here, is what this thing is telling me. Oh man, this is an even problem. I ain't gonna have my solution. Go back, double check. But it should be this. You should be able to sort of tell, like, just sort of relatively whether you're doing things correctly or not. So how do we get to X? Divide both sides by that thing that's on X. So 84 divided by 1.078. 77.922. And what are we talking about? What is the units on this X thing?
Percentage point?
Okay. No, this guy is a percent. So if I want to know percentage points, that would be like the 84 minus the 77.92. So there would be like a 6.8 percentage point difference, right?
Oh, okay.
Yeah. I love it. Let's get right up though. Good way. Think about this. So that is 77.92. If we want to think about this change, it's a change of 6.08 percentage points, or this thing is going up 7.8% is another way to say it. Okay. So back in 2000, what, 77.92% of households with television subscribe to cable. I can't imagine that's going up anymore. I feel like everyone's cutting the cable. Cutting the cable is the big thing now, right? I don't understand why people would want cable, to be honest. It's just like they bombard you with so many ads in cable. And every time I go and look back at it, I'm like,
they got a new technology out called TV Fix.
I just go with Netflix and Hulu, I guess. 89. Hulu's got enough ads as it is. They started putting them in. I remember when Netflix used to ship them to your house. But anyway, that's beside the point. With 2.4 million digital subscribers, Game Informer magazine ranked first has 11. Who's talking over me? Quit talking over me. Game Informer magazine ranked first has 1150% more digital subscribers than National Geographic, which is ranked third. How many digital subscribers does National Geographic have? Okay. So again, this is 1150% more. What are you doing? Blowing on your mic over there, Alec?
Oh, nothing.
Blowing out some candles? Okay. So, 89 says we're going up 1150. So this is a more amount. If I want the of amount, what would I have to do?
Are you at that location by chance?
We're going 1150 more. We're taking one of our things and we're adding 1150% to it. So what would that give us total? Maybe it's weird because it's a number way over 100. I don't know. We hadn't had numbers over 100 yet, I don't think. But this is back to the, if it's more than, we have to add what to this thing?
1,000?
No, not 1,000.
A 2.4 million?
We're adding 100. We're adding 100% back to this thing. So it should be 1250% of
100. Because it says more.
Game Informer has 1150 more than. It has 1250% of. What am I talking about?
Is it 2.4 million?
This one you have to be careful.
Okay.
Than National Geographic. So if this is more than National Geographic, this would be 1250 of the Nat Geo, right? Is what they're saying. And if we take 1250 of the National Geographic, that should be giving us the other thing, which is, I'm just going to read magazine. That we have the number for, that is 24 million, 2.4 million. So the first thing I should convert this thing to a decimal.
Okay, thank you.
So if I convert this to a decimal, what is that thing?
It would be 12.5.
Yeah, so 12.5 times National Geographic. That's something I don't know. And this thing should end up giving me what?
So is that 12 plus 12.5 times 2.4 or plus 2.4? Oh.
No, it's 12.5, and that X is the National Geographic viewers. That's the thing we don't know that we want to know.
So is it plus 2.4?
And that should be equal to what now? Be equal to 2.4. So how are we solving this thing?
We're going to have to divide by 12.5.
Yeah, so we're dividing both sides by 12.5. So we're going to take 2.4 divided by 12.5, 0.192. And what is that? You might want to put some units on there to go back what they're talking about. They're talking about 0.192. And they're talking about this in millions of subscribers. And does that make sense with what they're giving us, maybe, hopefully? If the Game Informer magazine is at 2.4 million and they're like 1,000% more than the National Geographic, then does it make sense that this would be a really small number like 0.192? Hopefully those things make a little sense. If you end up getting a larger number for National Geographic, you probably know something went awry, or that was just a really good episode of National Geographic or whatever. I don't know.
I don't know. I guess I'm kind of lost here because this isn't like using any of the formulas that are in the book that we were looking at. So
yeah, I'm trying to understand how okay, so at the last part where the X is in the parentheses, it's 12.5 times 2.4.
It's divide by. So you have to divide by 12.5.
So it's 2.4 divided by it?
This is sort of like the 100 plus P.
right, which is what I was trying to do, I think.
Yeah, and I kept getting 5.2083.
That's what I got too. Well, not 5.2, but 520.8.
Yeah, 2.8. Yeah.
2.4 divided by 12.5, is that what it did?
Well, no, I did 1150 plus 100, which gave me 1250, and then I divided it by 2.4 million. I'm assuming, okay, well, I'll figure out the million after that, and it gave me 520.8, which still makes sense to me, but I'm wondering if that's like, but you're the teacher.
Is it 5.2083? So you move the decimal over twice. So what is that, 20.8 or 52? How does is it 50? Wait, 52. Oh, there's a 1, 2. So is it 520.8?
I don't know what you're talking about right here.
The decimal, you move the decimal over. It's 52. It's 5.2083.
This is 2.4 divided by 12.5 is what you should be getting.
Yes, and I got 5.2083.
You have it flipped.
So that means I have to move the decimal over, right?
No, the 12.5 should be on the bottom. You're putting the 2.4 on bottom. You're flipping things.
Oh, 12.
So if you flip things, this is sort of like whether you're finding like the pre-tax or the retail price, right?
Mm-hmm.
So if we have the pre-tax price, it is like super straightforward. We're going to go.
Yeah, now I got 0.192.
Yeah, we're going to go. So we're going to go and we're going to figure this thing out. So we're going to do 100 plus the 1,000%.
Right.
But instead of maybe pre-tax, I'm talking about what number am I talking about? National Geographic, right? If I take 1,000% more on the new National Geographic, I should be spitting out the other thing, which is the game, right? So this is the one you have to do some back solving to figure out. If they gave us the number for National Geographic and told us it's so much percentage more, that would be the thing that's a little more straightforward. So we're taking 1,000%, but we're taking 1,000% of the National Geographic, which is the thing we don't have.
Okay.
We don't have. A little bit of back solving. And then the game is the 2.4. Right? So this one is going to require you to divide by the 1250.
Right. Okay, I see.
And so it's kind of like they're giving you a retail price and asking for the pre-sale price, or it's analogous to that sort of problem.
Mm-hmm.
And that is 89.93 says the unemployment rate. Told you we got to talk about wonderful things today. The unemployment rate has risen more than a percentage point to 8.5 in February from 7.1 last November. What is the relative change in the unemployment rate expressed as a percentage? So if you tell me 1.4, guess what? That's not what they're asking for here. That would be the percentage point. I don't want to spend too much more time. It's risen from that to that, so you want to know the change. We take that, and what am I dividing this over to know the percent change between these two things?
Is that 2?
So I'm doing 8.5 minus 7.1.
And then 7.1 is at the bottom,
7.1
right?
goes on the
7.1 going at the bottom. We want to figure out what this percentage change would be. So 8.5 minus 7.1 is like 1.4. 7.1 is 0.197. It'll be rounded up. So this is about what? Like, what would you say?
19.72.
Yep. So it's about 19.72%. Okay. So there's not nearly as many problems on the second set, I don't think. This is convert from one to the other. So if you need to spend some time on this and convert these things, go ahead and do that. But I'm probably going to do them fairly quick. If it's a positive number, should it get larger or smaller? Is that a weird thing to ask? This would be fine. Like 6 times 10 to the positive 4, is that getting larger or smaller?
6 times?
Larger.
Larger.
Larger. This is positive. It should get larger by 1, 2, 3, 4 zeros. Should be moving that thing 4 places to the right. B. No, 5 zeros, 1, 2, 3, 4, 5. Whip it good. I was watching Futurama the other night, and they're like, it had Devo on there, and they're like, "Are you gonna play Whip It?" And they're like, "No, we're gonna play the other song." It's like,
what you know about that Whip It? So that's 6,000.
That's 60,000. This is 300,000. So we're like literally just kind of filling in the zeros. But if there's that 4 is going to take up one of those spots. So now I only have, what, 4 zeros that I need to fill in? I think this should give me 340,000. All right, so I made them bigger. Now they're giving me negative exponents. Now they're going smaller. They should be going the other way. I have 2 decimal places right here. After this is 1, 2, 3. Hopefully you're telling me something like 0.002. Same thing here. I have to move it 2 to the left. 7. To the left. 1, 2, 3, 4, 5, 6. I don't want to count up all those little spaces, but it's going 6 to the left. It's like 1, 3. I got to go over. So there should be a total of 1. This would be what part F. Over these. Y'all should be able to do these sorts of things, I'm hoping. And if not, here's your practice. There's a few problems in the solutions are in the back too for all the odd answers. I don't know if you noticed that. But like a lot of your math books will have odd answer solutions in the back. We really don't care if you can get an answer. Like that's not going to help you too much in math class, just grabbing answers off of stuff.
So Professor, on the number E, you just did E, right?
Yeah. Right
so
here.
when you 6067 times 10 to the second, I lined up something totally different.
You're writing, this is a -2, so it moves 2 decimal places to the left.
Oh, that's why.
And so you got to fill in a 0 then. 1 0 you got to fill in.
0.
My hard drive has a capacity of 1.2 terabytes. Rewrite the following using a number and scientific notation. So tera means trillion. That's thousand. Trillions. Don't drive off on us. Okay. My hard drive has a capacity of 1.2 terabytes. And I want us to rewrite this in scientific notation. So I'm going to do 1.2 times. What power am I putting?
Would it be 12?
That's absolutely what power you're putting. You're just counting the zeros on this thing, basically, right? That is 23.
Quick question. At the end of that, do you have to put bytes as part of the answer?
You could. That's probably more proper. That's a good point. The diameter of a typical atom is 0.5 nanometers. 5. Nano means billionth. So just remember what a billion looks like. That's 1,000. Billions. I think you're talking about 9. So if you count them up, there's 9 spaces, but what should I put on that 9? And the key word being that this on billion is billionth, meaning it's a fraction, meaning we're doing 1 over a billion.
Jesus.
So it is a 9, but what should I put
That's
on?
9? Is that 10, 9?
What should I put on this 9? There should really be a
Negative.
A negative on this 9. Doing like 1.
Doesn't it have to be between 1 and 10 though?
This thing absolutely does. So we do need to fix this a little bit This number really should be, I don't know how they have it in the book, so I'll double check in just a second. But this number you should absolutely do to 5.0. And this is really confusing. But this is the sort of way that I go up, or I go about it, is that this is going from a half to 5. That went up. Guess what this has to do?
Down.
It's got to go down. So if we're at a -9, we're going to a -10. This is the same number. If one of them goes up, the other one has to go down for it to stay the same. And so if I move this up and this gets larger, this one's got to get smaller. Okay. So I know that's quite a bit, moving those things. It makes me think about it when I do it. So 23, 25, we did those two. Where are we at? We're like 3 minutes away from class ending, I think, right? We're going to have 35 is when we're in here. That's right. We got a few more extra minutes. 32, which is great. Use estimation, so I don't know, this will be different per person. I don't know. If you want to figure out something, throw some numbers down for that one. There's not really a right or wrong answer that I can really give you on that one. I don't know. I'm not in your life. Bugging around, seeing what jalopy you're driving, or what kind of whatever the heck you want to call food that you're ingesting.
So we didn't get no numbers. So you just add your own numbers, huh?
Yeah, this is just to figure it out in your own life. So life lesson, take it for what it's worth. Probably write something down for there so I can give you some credit for it, but I'm not going to be too picky if I'm being honest. Just pick some guesstimates. And I guess you, ooh, someone's playing bowling or something. So I guess.
Hold on. Someone's using the ice machine, so.
Yeah, it's really loud. So I don't know. This might depend upon what your Texas transportation looks like and where you live too, huh? If you ride the bus, then I'm probably going to say that you probably spend more money on food per year. If you don't ride the bus and you're living out of county, you're probably spending more on education, or transportation. How many average candy bars would? Ooh, that's right. I got to grab my table. Let me go digging through my table. 3B is what this is called. I did put it in my notes. I knew it would come up. So I talked a little bit about this. We can do really silly things. We can compare things that you normally wouldn't compare. If you look at this table, the energy released by metabolism of one average candy bar is 1 × 10⁶ joules. So 1 × 10⁶ joules is what you'd get from that thing. 8 hours of running. Now, where's the running? Energy needed for 1 hour is going to be 1 hour run is 4 × 10. And there are a sort of few ways you can do this. You can do this with like straight unit analysis if you really want to do like unit analysis. So I know I'm burning 4 × 10⁶ joules every 1 hour I burn. And I know every, like, what, 1 candy bar? One × 10⁶ joules. So if this is giving me 4 × 10⁶ joules for 1 hour run, They want to know for 8 hours of running. So how would you get to 8 hours of running from this thing? And there's a few different ways to do it, but if 1 hour is going to be 4 times 10 to the 6, how much is 8 hours going to be?
Is that 8, 10 times 10, 12? Is it double?
Is it 8 times? Are you saying to multiply this by 8?
Yeah.
That's exactly what you would do, right? So you do, yeah.
Oh, shit.
This would give you, yeah. So that's one way you could do it. What I'm doing is I'm doing like, well, if I eat 4 peas every minute, I don't know. How many peas have I ate in, 8 minutes? You're going to do the 8 times 4, right? I don't know. Something, this is a rate. But if we're looking here, the 2 things I really need to multiply are just probably the 8 and the 4. I talked a little bit about this, but with scientific notation, we can just kind of multiply those numbers in front. We can multiply the bases of 10 separately. 8 hours of running. So this is how many joules 8 hours of running is going to give you. Oh, I might have set this up just correctly. If I want to get rid of joules here, I'm going to have to kind of set them up differently. So there's probably other ways to think about this thing. But this is giving me candy bars per hours of running, is what units this thing would be in if I went straight across. Okay. So I'm looking across here, and on top I see 32 times 10 to the 6. On the bottom I see 8. And I can multiply 8 by 1 times 10 to the 6. And I talked a little bit about this. I can kind of look at these things separately. Like I can look at 32 over 8 separately from the 10 to the 6 over 10 to the 6. 32 divided by 8. I'm pretty sure that still gives me 4. Did I do this right? I did this weird. Yeah, I didn't have to do that much work. I could have done this simpler. I just realized it, but this still makes sense. Okay, so this is giving me, what, 32 divided by 8 is 4. This divided by this, what is this giving me right here?
Is that 0 or is that just states 10, 6?
So you're multiplying, and it's not multiplying by 0, it's multiplying by, that's a big fancy one. Yeah. So I think you're saying the right thing. What this looks like is candy bars per hour of running. I'm being honest. I shouldn't have done this to begin with. You can do it without doing this and figure out.
Yeah, I know you're running over, but what is the simpler way?
So the simpler way is to not convert it. Every 1 hour run. I should have done that times 8 thing. I don't know. I was thinking you got to multiply by 8, but you don't have to multiply by 8 till the end. I'm being honest. And so if we set it up like this with our unit analysis, we will get candy bars per hour of run. And this will give us the same thing that we just got. Number 1 times candy bars per hour of run. And so this should be giving us 4 candy bars per hour of run. And so this is for 1 hour of running. We need 4 candy bars. So for 8 hours of running, and this is the part where you should convert it to 8 hours, to be honest. So if you have 4 oh, sorry. Go ahead.
No, that's okay. So, I mean, we'd be back at 32 candy bars again?
Yeah, so 32 candy bars for every 1 hour of running, or 8 hours.
Wait, so the answer is the 32 or the 4?
The answer should be
the 32, okay.
For the 8 hours.
Okay.
It's 4 candy bars for the 1 hour.
For the 1 hour, okay.
Yeah. So these, this one's a little weird, but you should be able to sort of do these things. Like even on this one where I messed up a little bit, as long as I got my unit analysis and I know 4 candy bars for every 1 hour, I know it would be 32 candy bars for every 8 hours. Okay. And then 40 and 43, and I think I got like 5 more. Okay, so 40 says how many liters of oil are required to supply electrical energy for an average home for 1 year. So energy released by 1 liter of oil. The 1 liter of oil is going to give us, and we can kind of write these things 1.2 times. And electrical energy used in an average home daily, is that what they said? For the year. Did they give us? Looks like they're giving us it. I think we're going to have to multiply that by 365 to get the yearly. They're saying 5 times 10 to the 7th. So I'm going to have to multiply the daily by 365 to get there, I believe. Which is giving me 18.5 times 1 year. And so now they want to know how many liters of oil are required to supply electrical energy for 1 house 1 year. There are a few ways you could do this. And even the previous one, you can think about this. This is the total amount of energy we're going to need. So you can do a unit analysis. But this is the total amount of energy we need. And we're dividing this energy up into this thing. So it should look like this thing being divided by this sort of things. And I think if you just write them the way that I have them written out, if we just do this one times this one, right? I think we should be getting the same thing. The joules should simplify out, and we're going to get liters of oil per house per year, right? So we can do this with unit analysis. I want to save a little bit of time since we're going over now, but unit analysis works for these. And I'm getting something like 1520.83. This is what, 40. Oh, that's even. I ain't gonna have it back. Never mind. Okay, so that is 40, 43. What do they say? If you could generate energy by fusing the hydrogen and water, how much water would you need to generate the electrical energy by 10,000 typical homes? So it's the same thing. We're taking this chart. We're seeing the daily energy by a typical home is 5 times 10 to the 7th. And we'll multiply this. I'm going to rewrite this as 10 to the 4th power. So instead of doing 10,000 typical homes, I'm going to do 10 to the 4th is another way to write 10,000. So if I want to know how many 10,000 homes, how much electricity 10,000 homes require, I have to multiply these two things. I should be getting 5 times 10 to the what, 11? This is one home by 10,000 homes, right? That's what we're doing. We'll give you the 10,000 homes, or 5 times 10 to 11 joules. By fusing hydrogen, let's say by fusing hydrogen, energy released by fusion of hydrogen in 1 liter of water, 6.9 times 10 to the 13th. One liter.
Six 6.9 times 10.
Yeah, 6.9 times 10 to the 13th. And that's hydrogen in 1 liter of water. So they want to know how many liters of water we're going to need. It's going to be really low, right? Am I thinking about this right? I hope I'm thinking about it right. 43. Yeah, okay. So there are a few ways we can set this up. If you want to do unit analysis is always a good way to go about it. But we're dividing these things. And so what's the total thing we want to divide, and what do we want to divide it by? So the total amount of energy that we need to supply is what? This number right here. So this is the total amount of energy we need supplied, is the 5 times 10 to 11 joules. And we're dividing that into hydrogen ions to see how many hydrogen ions we need. And so this should be the 6.9 times what, 10 to the 13th joules. And so right away, you could probably already tell this is going to be a small number. It's going to be a relatively small number of liters of water. So they're doing 5 divided by 6.9 is giving me 0.57 is what they're doing in the notes. 73. Are we doing chapter P exercises? What? 43. Okay. Let me double check, make sure. That sounds like what they're doing. Let me see. 0.07. I don't know what it's, oh, 5 divided by 6.9. That might help. So we can look at these things kind of separately. Move it up. We can look at like the whole numbers separately from the powers of 10. And if we do 5 divided by 6.9, it's giving like 0.72 times 10. And I talked about this in my notes, but if I want to do times 10, this is to the 11 minus 13 is going to give me minus 2 there. And so they converted to standard notation, so we're moving this 1, 2 spots to the left of 0.0072, and this is liters of water. Okay. There were approximately 2.69 million deaths in the U.S. in 2015, expressed as quantity in deaths per minute. So in case you didn't think we're going to talk about wonderful things today, 2.699 looks like 2.69 times. And we got this deaths per year. And we want to express this in minutes. So we need to go from years to days. From days to hours. 1 day is 24 hours. And then the last thing is what? Hours to or minutes. All right, your day on top of it. Hours and minutes. So 1 hour, 60 minutes. So there are a few ways you can do this. If you have a calculator, this might be easier. 365.25. I'm getting something like 7364.82. Then I divide this by 24. I'm getting something like 306.87. And then the last step is I'm going to divide this thing by 60. I'm going to get something like 5.11. Or you could say there's about 5 deaths per minute. Okay, so we got 2, 3 more. Okay, so 63 says this estimates the number of cells in the human body, and assume the average cell has a diameter of that thing, which means the volume is 100 micrometers. How many cells are there in a cubic meter? Or a cubic centimeter? Estimate number of cells. I feel like is this odd? This is an odd one. I'm going to leave that one to y'all to do, I think, and do these other two. Okay, so National Geographic contained the following statement: dropping less than 2 inches per mile after emerging from the Andes, the Amazon drains a sixth of the world's runoff into the ocean. 1 day discharge at its mouth, 4.5 trillion could supply U.S. households for 5 months. Did I not cut that? Ooh. I think I didn't copy all that problem down. So that says,
based on the statement, it says determine how much water an average U.S. household uses each month.
Yes, so determine how much water an average U.S. household uses each month. So they said that this 1 day discharge could supply U.S. households for 5 months. So we're starting out with 4.5 trillion. 4.5 trillion is times 10 to the 12th. And if this supplies it for 5 months, we want to know for 1 month, what are we going to do with this thing? be dividing it by 5 to figure out what happens for 1 month, right? That's good for 5. We want to know a fifth of that. So again, we have this sort of thing. 4.5 over 5 is giving me 0.9, and this is times what, 10 to the 12th. This one larger, I have to make this one like 1 smaller. So I think it should be 9 times 10 to the 11th. And that was what, 65 that they're doing that on? Yeah. And so the last one, 69. The Bureau of Economic Analysis estimates that in 2015, personal consumption expenditures of Americans totaled 12.93. Where were we at? If I'm being honest, I think we got plenty of practice today. If y'all complete like what, 63, I think that's pretty good for homework. I feel like we're just getting into overkill at this point, kind of, on this stuff. And this is a really wordy problem. I don't know. It's been a long day, and we've had long enough. If y'all want me to go over this one, I can go over this one. But like I feel personally like we've had enough, sort of.
Just this one, this last one. I'll do the other ones. Just do this one.
Do this one?
Yes.
Okay. The Bureau of Economic Analysis estimates in 2015 personal consumption expenditures totaled 12.3 trillion. The major categories of these expenditures were durable goods, 1.36, non-durable goods, and services. What was the annual per capita spending on personal consumption? On consumption, so the major categories, 12.3 trillion is what we're doing. So they're giving us this number, 12.3 trillion. This is our extent. And I want to know, if the population is 321 million, what is the spending per person? We take the spending and we're going to have to divide it by what? The person. And 321 million is times 10 to the 6. And so this is 12.3 over 321 is the number that I'm doing here. So I'm looking at these kind of separately. This is 0.0384, somewhere around that ballpark. This is 10. And now I'm doing 12 minus 6 for the power. So 12 minus 6 is giving me times 10 to the 6. So they probably want this in standard notation, considering there's like 4, 5, 6 spots that we have to move. So if we move 4, we have to move 2 more spots. I think that's giving me 38,400 per person. Okay. Part B says, what is the approximate daily per capita spending on personal consumption? So this is annual. If I want to get from annual to daily, what do I do? And you can use unit analysis if you really wanted to. But if this is happening 365.25 days of the year, then each day we're going to have to divide this by 365.25. So I'm getting something like 105.13 if I round it. ABC part C says, where is it? On average, about what percentage of personal consumption spending was devoted to services? Is this figure consistent with your own spending? So part C is asking about services. So if we're looking at services, services are giving us, where are they at? Services are 8.3 trillion. So we're comparing 8.3 trillion to all the money spent, which is 12.3 trillion. And I wrote trillion in a really kind of lazy way. But if these are both trillion, I really don't have to worry about the sort of trillion being there. I just got to worry about the 8.3 over the 12.3. Only like 0.6747. 67.47% of the money being spent is being spent on services. D says spending on healthcare was estimated to be 2.1 trillion. About what percentage of all personal consumption spending was devoted to healthcare? So personal consumption spending total was still 12.3 trillion. Now we're trying to figure out what 2.1 trillion would be. These two, they're just asking you for like the sort of fractional percentage amounts. And this one, I'm just going to convert it right quick, 17.07%. I do a percentage. So it should be giving me 0.1707. And the last thing, in 2000, total spending on personal consumption was 6.8 trillion, while healthcare was 918 billion. Compare the percentage increase in total spending in healthcare between 2015 and 2000. So they're giving me two different amounts now. Healthcare went from 918 billion to 2.1 trillion. And then the total spending went from 6.8 trillion to 12.3. And we want to know the percentage increase. Okay. So this is billion. If I want to convert this to trillions, that might be the easiest thing to do. I want to move this 3 decimal places to convert it to trillions. So if you want to convert this thing to trillion right off the bat, that's probably what I would do. It would probably help you. 0.918, and we want to know the relative change, the percentage change in this thing. And so this is my healthcare. And then I have one that's the total spending. But for my healthcare, this thing should be like 1.288. 1.288. So this is 128.8% increase. This one is the total, so 12.3 minus 6.8 divided by 6.8. This should give me something like 0.8088. 0.88%. And that's the last problem. I'm going to hit stop on the recording, but I will